Okay, so here we've got a question here. We have to derive this one here. Y equals 3x to the power 4, the natural log of x. So whenever you see two terms that are not similar, okay, we've got a natural log and we've got an algebraic term here. Whenever you see them close together like this, then you know you're using the product rule. Okay, so let me write down the product rule. Okay, this is the product rule. This is a simplified way to write it. Okay, so what's going to happen is you're going to pick which one is your f, then you derive it. Which one is your g, then you derive it. Okay, so in this question here, y equals 3x to the power 4, natural log of x. Our f, we say, is going to be 3x to the power 4. Then this f prime, when you see this f with a sign like this, it just means you're deriving f. Okay, so f prime, so we're going to derive it. So as I said, when you're deriving, you multiply the exponent. So this power 4, multiply it with the coefficient. 4 times 3, that is 12. Then the exponent, you're going to subtract a 1. So 4 minus 1, that is 3. Any questions before I move further? We are going to pick our g. G equals the natural log of x. So g prime, it means we are going to have to differentiate the natural log of x. So this is how you derive natural logs. Okay, whenever you're deriving a natural log of x, it's equal to x prime divided by x. Meaning, whatever value you're deriving, on the numerator, you derive that actual term or expression. Then in the denominator, you leave the expression or the term as it is. So let us apply it to here. We derive the natural log of x. Okay, so the derivative of the natural log of x, in our numerator, we have to derive x. Okay, so here we're going to have to derive this x here. So x is the same as x to the power 1. So when you're deriving the exponent, multiply it with the coefficient, 1 times 1, that is 1. Then you subtract the 1 from the exponent, 1 minus 1, that is 0. So you have 1 x to the power 0. Now, if you remember, according to the rules of indices, x to the power 0 is 1. So this x to the power 0, you don't need to show it here. Okay. So in the numerator, you derive the expression. Then in the denominator, you leave the expression as it is. So 1 over x. So the derivative of the natural log of x is 1 over x. Any questions? So this is the rule first. This is the rule. When you're deriving the natural log of anything, in the numerator, you're going to derive the expression, whichever expression you are given. Then in the denominator, you leave the expression as it is. So let me just show you an example so that you can see this clearly. Okay, for example, if you want to derive the natural log of x squared, okay, want to derive the natural log of x squared. In the numerator, we are going to derive this x squared. Okay, when we derive x squared, we get 2x. Okay, the numerator here where it's written as x prime, it means you're deriving whatever expression you're given. And in this case, the expression is x squared. So in the numerator, we've derived x squared. Then the denominator, you just write the expression as it's given to you. As you can see here, this is the expression x squared. And then when we simplify, this becomes 2 over x. That's, yes, you can go ahead. Was that Mr. Peter asked the question? So, ha! Eh, mm. Okay, it erased this one. Yes. So for example, here's just another example. So we're getting the concept. If you have to derive the natural log of x to the power 3, okay? In the numerator, you derive the expression given to you. This x to the power 3, you derive it, it becomes 3x squared. Then in the denominator, you just leave the expression as it is, x to the power 3. Then this x squared goes, we remain with an x in the denominator. So our expression is 3 over x. Any questions, colleagues? Ahem. Here on the numerator, there are two x's, x times x. In the denominator, there are three x's, x times x times x. So in the numerator, 2 go. In the denominator, 2 go. So you remain with 1 in the denominator. What about from the others? Madam Joyce, we'll start with you. Are you okay with this? Madam Lily, Mr. Mavins. Okay, don't worry. After these questions, we're going to practice some more questions. Madam Purity, Mr. Fumbeshi. Okay, wonderful, wonderful. Okay, so the natural log of x, when you derive it, 1 over x, okay? As I said, the rule is whatever expression you're given on the numerator, your answer will be a fraction. On the numerator, derive the expression, the denominator, leave the expression as it is. So here, we now just a matter of substitution. F prime is 12x cubed. G is the natural log of x plus F is 3x to the power 4. G prime is 1 over x. Now, we can simplify this answer further, okay? We can simplify this answer further, okay? This x at the bottom, it will cancel one of these x's, so we remain with 3x to the power 3. Okay, colleagues, are we okay with how we've got that 3x to the power 3? 3x to the power 4. 3x to the power 4, right? 3 times x, 4x is here. Okay, multiplied by 1 over x. One x cancels, another x cancels. So we've remained with 3x's, right? That's how we get 3x to the power 3. Is that okay, Mr. Peter? And the other colleagues, is that okay? How we've remained with this 3x cubed. This x at the bottom has cancelled one x from this 3x to the power 4. Okay. And we can simplify this answer even further. Okay. We can factorize it because 3x cubed is also divisible by 12x cubed. Okay. So if you can factorize the common factor here, 3x cubed. So 12x cubed divided by this 3x cubed, you get 4 natural log of x. Okay, this x in the natural log, don't try to cancel it out with anything. Okay, colleagues? Plus 3x cubed divided by 3x cubed, that is 1. So we can simplify our answer to this. Any questions, queries, clarifications? Yeah, I think do that because if the network is bad, it will be skipping for you. And this topic, you need your network to be well and good. Try to put it on flight mode and try to come back on it. Is everyone else's network okay? Do we all have good networks? Those who have bad network, try to just put on flight mode and think. But any questions so far here? Remember, ask before we go further, because the next question is another rule. But we'll be deriving, but it's another rule. So we don't want the confusion to start building up. Um, I never heard what you said. Through the whole question again. Okay, let's do this. Let me finish explaining. Okay, let me finish explaining, then we'll start doing some examples. Is that okay, madam? It's yes, yes. It's understandable because in the assignment, your lecturer has brought questions from everywhere. So yeah, it won't be easy just to grasp the concept just here. So let me just finish these ones here. Okay, just listen in. Okay, then after the recording is done, we'll do some examples. Then you can watch this recording again. Yeah? Yes, I'm recording actually here. Okay, so when your children watch this recording, they'll be like, but so dad, you got confused there. Yeah, they're going to come, dad, mommy. So that's how you got confused. Okay, we got to part B. Okay, so just hang on tight and just listen in, okay? Just hang in tight. Okay. So now here, when you see two terms are being divided, you use the quotient rule. Okay, so the formula for the quotient rule, F prime G minus F G prime divided by G squared. Now, colleagues, in the exam, they're not going to give you this formula. That's the problem. That's where the issue is. Okay, so the more we practice, you'll remember this formula. In other books, they'll write it in a complicated way. So at least this way is easier. Other books also use U and V. So in our equation here, it's just for you to pick what's going to be your F, what's going to be your G. So here we say, okay, our F is going to be this 1 plus x squared. Okay, this is our F. So F prime, it means we derive this. Okay, so when you're deriving, when a number doesn't have a letter, okay, in differentiation, the number disappears. Okay, I believe I showed you last time how the number disappears, right? So this one, it disappears. This x squared, remember, exponent multiplied by the coefficient 2 times 1, that is 2. In the exponent, subtract a 1 from it, 2 minus 1, that is 1. So when we derive 1 plus x squared, we remain with 2x. Okay. Remember, whenever you have an exponent, a number without any letter, you don't even need, just it goes, okay? It disappears. We pick our G. Our G is e to the power 2x. So this is how you derive e, which is Euler's number. The derivative of e to the power x equals e to the power x multiplied by the derivative of x. Okay, that's how you derive e. Okay, you just write the same e expression here, then whatever the power is, the power you need to derive it. Okay, so here we have e to the power 2x. So we're going to write it e to the power 2x. Then we're going to derive this 2x. Okay, we derive this 2x. 2x is the same as 2x to the power 1. When you're deriving, exponent multiplied by coefficient, 1 times 2, that is 2. Subtract a 1 from the exponent, 1 minus 1, that is 0. Okay, so you have like 2x to the power 0. Okay, but remember, anything to the power 0 is 1. Okay, so this is how we've derived e to the power 2x. You just write the expression as it is, then you derive the exponent. Okay, you write the expression as it is, then you derive the exponent. So g prime here is 2e to the power 2x. So we substitute into our formula here. F prime, let me write the formula here first so that when we substitute, it is flowing. Okay, so we substitute. F prime is 2x. G is e to the power 2x. Minus f is 1 plus x squared. G prime is 2 e to the power 2x. 2e to the power 2x over g squared. So g is e to the power 2x, so it's e to the power 2x squared. So you can also factorize this one here. Okay, we've got common factor. You can leave your answer like this, but you can also factorize it. Okay, we have a 2 here, a 2, and e to the power 2x here, and e to the power 2x. So our common factor is 2e to the power 2x, open brackets, 2x e to the power 2x divided by 2e to the power 2x, that is x, minus this whole expression divided by 2e to the power 2x. The 2e's to the power 2x's cancel, so remain with 1 plus x squared over e to the power 2x squared. Okay, let me do the last one. Then after we do that last one, we can now start practicing this differentiation. Okay, colleagues, after this last one, then we can now practice. Okay, we need to derive y equals x to the power x. So here what needs to happen is we need this exponent to become a normal variable here. And the way we do that is we introduce a natural log. So it's a natural log of y equals this x power now comes here, x natural log of x. Okay, so now here we've got two variables that we're dealing with. There's y and there's also x. So we need to derive this natural log of y, we need to derive this x, and we need to derive this natural log of x here. So here, two rules are going to be at play. Here on the right hand side here, we're going to apply the power rule. Okay, because this x and the natural log of x, they are different components or different terms. Okay, so here we're going to apply the power rule. Then on the left hand side, okay, since here we are deriving y, we're not deriving x, we're deriving y. Okay, so here we're going to have to use implicit differentiation. Okay, so let's start first with the right hand side with the power rule, which we're familiar with first. Remember the power rule, f prime g plus f g prime. So you select your f, we say okay, f in this case is x. Okay, this x here. So f prime, when we derive x, you get a 1. Okay, remember this is x to the power 1, exponent multiplied by coefficient, 1 times 1, that is 1. Then you subtract a 1 from the exponent, you get a 1x to the power 0. And a 1x to the power 0 is the same as 1. Our g, in this case, is the natural log of x. So our g prime, when we derive, remember when you're deriving a natural log, you get a fraction as the answer. In the numerator, you differentiate whatever you're given. In this case, we've been given an x. So if we differentiate x, that gives us a 1. Then in the denominator, you leave the expression as it is. So this x here will come in the denominator, 1 over x. Okay, so on our right hand side, f prime, that is 1. G is natural log of x, so 1 natural times the natural log of x plus f, which is x, times g prime, 1 over x. And if we simplify it, it becomes natural log of x plus these x's cancel each other, so you have a 1 here. That is on the right hand side. Now on the left hand side, okay, because the natural log came on this y, that's why we need to derive y. Okay, because this natural log came here, so y has to be derived. So as I said, we're going to use implicit differentiation. Now with implicit differentiation, colleagues, since you're not deriving x, you're deriving another letter. So after you derive, you're going to attach a dy dx. Okay. So this natural log of y, the same way we derived this natural log of x, the same way we're going to derive this natural log of y. Okay. The derivative, as I said, you derive y to the power 1. If you derive it, 1 times the coefficient, that is 1. Subtract a 1 from the exponent, 1 minus 1, that is 0. So in your numerator, you get 1y to the power 0. Y to the power 0 is equal to 1. So you don't need to show the 1y to the power 0. Then in the denominator, okay, we're just going to put a y. The same way we derived the natural log of x, the same way we're deriving the natural log of y. The only difference is we're going to attach a dy dx to it. Okay. So now, once this dy dx has come into the equation here, we have to make this dy dx the subject of the formula. Okay. So the way our expression is 1 over y dy dx equals natural log of x plus 1. So we want this dy dx to remain by itself. We want to get rid of this 1 over y. So the way we can do that, we multiply both sides of the equation by y. Multiply this by y. Multiply this by y. So these y's here on the left-hand side, they cancel each other. So you have the expression here, dy dx equals y times natural log of x, y natural log of x plus y times 1, that is y. Okay, so this is the answer for the question.